Good morning, everyone. We are almost set to go. So you should have your quiz with you, your test quiz, whichever it was. The thing I sent you last week, have it with you. The one with the Sanga's fishing as the last question. We're going to be going over those answers this morning. And what a great time we will have. All right. Class to start in just a couple of minutes. I got 13 of you up there now. Very nicely done. You guys probably hear me washing my coffee cup. It's kind of fun, kind of neat. There's a quiz you should have out with you now. Your quiz that you had, it's the one I sent you last week. Your quiz is the one, the Sanga's fishing, all those great things like that. Amazing. This is the last class before a test on this stuff. Sorry, now my sink is dripping, which you can probably also hear. Okay. If that noise bothers you, it should stop in a bit. Let's get set and let's go. So for last week, we had an assignment. It was due by Friday. Good news, everyone handed it in except for one person. You know who you are. So we're pretty good in this class of everyone getting their assignments in. That's fantastic. Let's see what we have from our quiz. Have your quiz out with you. I'm going to go through the answers today and explain a bit how we got all those answers in preparation for your test that is coming up today. Today's when I will email you your test for this unit, and I'll explain the process that we do for that. It's going to be much like the process we did for this quiz, that I give it to you, give you lots of time to work on it, and then we will meet together to mark it. So let's have a look. Question number 1 on your quiz, you were asked to find the critical numbers of f of x equals 5 plus 6x minus 2x cubed. That's amazing. So what we can do with that, 5 plus 6x minus 2, where the curve changes. So if you're thinking of a parabola, a critical point would be the vertex. If you're thinking of an x cubed graph, those 2 points that where the graph changes direction, those are critical numbers. So what we do is if we want to find a critical point of a function, if you remember, take the derivative of the function. So taking the derivative of f of x is 6 minus 6x squared. And then if you have a critical point of a function, it must mean that that derivative equals 0. So there's your steps. You take the derivative and then set the derivative equal to 0. Doing that, take the negative 6x squared to the other side. 6x squared must equal 6. You can then divide both sides by 6 and x squared equals 1. Take the square root of both sides, you get a plus or a minus 1. And just like that, bam, that first question is out of 3 marks. You'll always see the marks in the bottom right corner. So your 3 marks, you assign yourself a mark out of 3 now. If you were perfect, if you showed your work well, you showed the derivative of f prime of x, you set the derivative to 0. You then did your algebra to reduce it down to x squared equals 1. You then have a lovely answer of plus or minus 1. Give yourself 3 marks. If you kind of did it, but you know that your work is garbage, if you skipped steps, your notation was shorthanded and everything else, give yourself like 2.5. Maybe you missed the plus or minus 1 and you just said 1. Then you can give yourself 2. If you knew to take the derivative but didn't know what to do after taking a derivative, give yourself 1 out of 3. If you didn't know how to do this at all, you forgot what a critical number was, you didn't look up critical number, you did nothing, and your first question's blank, that's how you get a 0. Otherwise, if you started showing some initiative, you get half marks. So this is where self-assessment really comes in. Ask yourself, out of 3 marks, how much should I truly get? And you give yourself, honestly, 3 marks. Remember, you're self-assessing at the end of the semester. You can give yourself 0 and still ask me to give you 98. I still will. So be honest with yourself. When I'm doing trivia at night, our first game when we do trivia, it's the just for fun game, and you mark your own answers. And people always say, "Oh, I got all of them right," but they're cheating. They're looking it up online. And I always say to them, it's like cheating when you're stretching before a long run. Go ahead, tell everyone you stretched your calves out, and then go for a long run. It's going to be pretty obvious you didn't stretch once your calf pulls up lame. So give yourself a mark, self-assess. At the end of the year, I'm giving you the mark you want. Everything will be fine. Up next, it is our next question. Mr. Klein's dodgeball game. Hala and Miriam had to make up their own game because sadly for Mr. Klein, he can't play dodgeball anymore. So there was a bunch of context, but the gist of the question was, the radius of the ball is increasing at this rate. As you're doing these word problems, you can read through the word questions right away and start to pick things out, key points in the text. The radius is increasing at a constant rate of 0.04 centimeters per second. Stop right there. Thank you very much. What is that? Radius is increasing at this rate. Radius and rate. My goodness, that first sentence, there is your dr dt. So rather than scribbling over top of the question, because that's not very good university math, on a scrap piece of paper, feel free to just write for this question, dr dt, it's 0.04. At the time when the radius of the ball is 15 centimeters. Whoa, stop again. What did I just tell you? There's your R. So now in the first two sentences, you have dr dt and you have R. And what's the last thing asking you? What's the rate of increase of the volume? Amazing. Again, what is the rate of increase of the volume? Rate, volume, that must be dv dt. So now on your scrap piece of paper, you've got dr dt, you've got R, you've got dv dt. Now look at that. Because in university, they're not going to give you formulas. They're not going to walk you through it. What do you need? We've got radius. We've got volume. It's a sphere. Radius, volume, sphere. Bam! There is how you start. We're going to relate the volume to the radius. And we know the formula is 4/3 pi r cubed. Now, to get all these rates that we need in our related rates, we're going to take a derivative with both sides with respect to t, and we've done this multiple times now. The derivative of v is dv dt. 4/3 and pi are constants. They stay right where they are. Take the derivative of r cubed with respect to t. That's going to be 3r squared, and then our dr dt will be at the end. So there's the formula we have. And what do we know? Well, we know everything. We were asked to find dv dt. There's your 4/3, that's a constant. There's pi, that's a constant. 3r squared, you have it written down on your scrap paper that r is 15. dr dt, that's how fast the radius is changing. You've got that written down, and Fantismo, you now have dv dt, which is what we're trying to find. There's your 4/3 times pi. 3r squared now becomes 3 times 15 squared, and dr dt is 0.04. Slap it all together, and you've got your dv dt equaling 36 pi centimeters cubed per second. Remember, volumes in terms of centimeters cubed, and because it's a rate, it's centimeters cubed per second. And for that, we're getting a whopping 3 marks. And that's good. So I'm typing in the comment, all good, because everyone's just saying hi. No one's saying, oh, my screen's black. No one is saying there's no sound. So I'm assuming it's all good. We don't need all of you to say it's all good. Once you see the comment that one person says it's fine, then I'll know. Yeah. Okay, there we go. Okay, we got enough. So now give yourself a mark again out of 3. So did you get everything? Did you show your work properly? Give yourself 3. Did you leave it blank? Give yourself 0. Other than that, be honest with yourself. How well are you doing in this stuff? Show your work properly on these things. We don't have too many questions. Up next, the sand challenge. And this was considered to be a tougher of the questions on the test. Let's see what happens here. We're going to go through the question just like we did in the last one. Sand is falling off a conveyor onto a conical pile. Yes, it's really funny, but it's not that conical. At a rate of 15 meters cubed per minute. Stop! What does that tell you? 15 meters cubed. That sounds like volume to me when the meters are cubed, but it's meters cubed per minute. So what there's a fruit fly that is, sorry, if you hear me clapping, there's a fruit fly actually buzzing right above where all my keypad is, driving me absolutely nuts. Oh, Colleen, your question about why do we leave it as pi? If we multiply it, you might be able to give me 3.14. You might have to give a lot of decimals. If we put pi in there, we are now correct to a billion decimal places. And as Sawyer says, first of all, you'd have to grab a devil board, which you don't want to do. And after that, whatever answer you have, you can give me 8 decimals. That's still an approximation. And this is one of those things, if people always say, well, this isn't rocket science. Actually, it is. This is how they launch rockets. And if you are off at the 25th decimal when you're doing a rocket launch, you might shoot for the moon and end up on Uranus if you don't have all your decimals carefully in line. Leaving it as pi will correct it to billions of decimal places. That's why we leave it as pi. If you do multiply it out, well, yeah, you don't give yourself less marks, but just know your answer isn't as good. And besides, not everyone can quote 200 decimals of pi. Colleen. All right then, sand falling off a conveyor onto this 15 meters cubed per minute. Bam, that is how fast the volume's changing. That's dV dt. The diameter of the base of the cone is twice the height. Oh, now we have height. We have the diameter. Diameter sounds a lot like 2 times the radius. So we have radius, height, volume. At what rate is the height? Frickin' fruit fly! I think I got it. At what rate is the height of the pile changing when it's 10 meters high? Yes, it could be, Colleen. I think they are best friends. I should introduce my fruit fly to your house aunt. Maybe they'll elope. At what rate is the height of the pile changing? If it's a rate of a height, look at the last words there. Rate is the height. I'm asking you to find dH dt. So let's go through and see what we got. First of all, we know it's a cone. And the volume of a cone, remember, if you're doing this without formulas, the volume of the cone is always going to be the area of the base times the height. I'm so distracted by Colleen's aunt story. The circle is what's on the base. Multiply it by the height. So what's the area of the base? Area of a circle is pi r squared. Now multiply it by the height. That's h. But remember, it's a pointy thing. And pointy things always get a third in front of it. So that's how we get this formula. Pi r squared, there's your base. Multiply it by the height. If this were a cylinder instead of a cone, pi r squared times height, you wouldn't multiply it by a third. It's not a pointy thing. But hold the phone, Baba Louie. Notice we have 3 different variables. We have volume, we have radius, and we have height. Now, you can use the product rule if you want, but that's making this incredibly difficult. In the thing I sent you, I did say, hint, 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 look to see if you can reduce one of the variables. So notice this. In the question, it says the diameter of the base is always twice the height. So that's what the first part of this says, since the diameter is twice the height. But remember, the diameter is also twice the radius. So if the diameter is twice the height and the diameter is twice the radius, doesn't it make sense to you, since they're both the diameter, that twice the height is the same as twice the radius? So r must equal h. And now we can substitute that back in. Reformat your equation. If r is the same as h, now which one do we change? Do we change all our r's into h's, or do we change our h into an r? Go back to the equation. Notice what I asked you to find? At what rate the height of the pile is changing. Since I'm asking what the height of the pile is, I need my h's. If I asked the same question but said, at what rate is the radius changing? Well then, I would need to change all these into things. I've also given you 10 meters high, so we've got a lot of height going on. I'm going to reformat this, and since r is the same as h, I'm changing all my r's into h's. We now have 1/3 pi h cubed. That is the formula I can use to do this one. And that is what will make this amazing. Because now watch what happens. We now need to get dv dt, we need a dh dt. So I'm going to derive both sides with respect to t. There's my dv dt, Fantismo. And notice the 3 that's with the h, when it comes down to the front, it wipes out that 1/3. So now we just have pi h squared, because we took the derivative, and we have our dh dt. So there's your formula. Now, what do we know? What do we have? Sand's falling off at 15 meters cubed per minute. There's our dv dt. Pi is a constant. H squared in the question, the very last thing there, it says the height is 10 meters high. So you can put 10 there and squared. And now we can find our dH dt. So all we would need to do now to get dH dt by itself, divide both sides by 100 pi. And of course, you can reduce that if you'd like to divide them both by 5. 3/20 pi is also an excellent answer, probably even a better answer. And we leave the pi in there. Otherwise, you've got, because pi is an irrational number, pi never terminates or repeats. So by actually trying to put pi in there, we are dividing by an irrational number. Crazy. We want to keep it like that if we can. If you did reduce it to decimals, yes, remember decimal and demon, it starts with the same letters. So let's keep them as fractions. Fractions are fun. Give yourself 4 marks if you nailed it. If you got all of it, give yourself 4. And when I say all of it, you have a very, very good explanation as well as to why you just all of a sudden got rid of the R's and put in H's. And you showed great work. That's a 4 out of 4. 4 out of 4 on this question means you just absolutely nailed it. If you butchered this thing, but you gave it a good shot, you can give yourself 1 out of 4. If you left it blank, so blank is a 0. If you tried taking a derivative and then used the product rule, got all mixed up, that's a 1, 1.5. You need to make some progress there with this. All right, then. So your hint with these is always if you start using the product rule and then you find you have an R and a dr dt, but nowhere in the question are you given an R or a dr dt, that's when you might want to change it up. Finally, we go fishing with the Sangha Boys. What we'd all like to do, there's a band called the Venga Boys. It's kind of the same as the Sangha Boys. Listen to Venga Boys, Venga. We like to party. We like to party. That's the Venga Boys, kind of like this question here. So there was a much more detail in your actual question. The fish is traveling east along a line 30 feet north of the angler, in this case, the Sangas. If the fishing line's leaving the reel at 6 feet per second when the fish is 50 feet from the Sangas, how fast is the fish traveling? So let's have a look and just see how we do this. First up, there they are. The Sangas all set to go fishing. One, obviously, picture day is always Thursday. One of them obviously had me first semester as they were properly dressed on a Thursday. The other one can't help it if it was a scrub Thursday among him and his friends. But here we go. What do we know? The fish starts off. See, just north of the Sangas, there was this beautiful fish. But then the fish started traveling. The fish starts leaving and is going that way. Okay, fish starts here. Fish no longer there. Now fish is over here. The Sangas, however, have hooked the fish. So you can see the farther the fish goes towards the east, the longer that line is going to become. So let's see. Remember, when we're doing these angle problems, we need 2 sets of data. We need a triangle that's changing, and we need a triangle that's static. So first, our static triangle. We need, well, let's go with our y. if we're looking at the y component of this, how far north, or what is the y component of this? We were told that's 30. That's one of the first numbers we have. The fish it started off 30 feet north. Well, what about Z? Z's the hypotenuse, and it says right near the bottom, when the fish is 50 feet from the sangas, so there's your 50 feet for the fish. Now, we need to find X. We need to find that horizontal distance from where the fish started to where it is now. Must be some way we can do that. Wish there was some way to solve for a third side on a right angle triangle. Oh yeah, there it is. It's 40. You've now got an X, a Y, and a Z. Super. Now let's look at our moving triangle. The magic triangle that moves, dx dt. That is how fast x is changing. Do we know what dx dt is? Look at the very, very last 6 lines of what I have written on your screen. How fast is the fish traveling? No, we don't have it. So we need to find that. That's our unknown. What about dy dt? Dy dt, that's how fast y is changing. So look at this triangle. Imagine the fish is moving. So yes, x is changing. Imagine as the line goes out towards the fish from the boys, as the fish gets further away, that's changing. Look at the y component of this triangle. How fast is it changing? It is not changing. Dy dt is not changing at all. The y value is staying the same, so dy dt is 0. Dz dt, that's how fast the hypotenuse is changing. And if you look in the middle of the words that I've got there, the fishing line is leaving the reel at a rate of 6 feet per second. So there's our dz dt. Okay, we've got it all. We've got all our components that we need. We're now ready to start our triangle question. The sangas go fishing. There was a fish right